Hello everyone, this is Sravanthi, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today we are going to discuss about this introduction to batteries, classification of batteries, and what are the difference between primary batteries and secondary batteries. And mainly primary batteries, best example is Zinc air battery. So what is battery? So battery is a device in which two or more electrochemical cells connected in a series is called battery. Two or more electrochemical cells means, what is the meaning of electrochemical cell? Which converts chemical energy into electrical energy is called battery. So battery is a device in which two or more electrochemical cells connected in a series is called battery. So electrochemical cell means which converts chemical energy into electrical energy. Generally each cell, it consists of one anode and one cathode. So in this battery it consists of two or more electrochemical cells. That means it containing two or more anodes and two or more cathodes is called battery. So battery is classified into two categories depending on their rechargeable capabilities. Based on this rechargeable capabilities, batteries are classified into two types. So one is primary batteries, second one is secondary battery or secondary cell. So batteries are classified into two types based on their recharging capabilities or recharging capacity. So based on this, batteries are classified into two types, primary batteries and secondary battery. So what is the meaning of primary battery? The cell reactions are not reversible or irreversible. Not reversible. These cells are called primary battery. So the cells in which the cell reaction is not reversible are called primary cells. That means the cell reactions takes place only one way direction. Once reactants converts to the products, it becomes dead. Simply we say use and throw batteries are called primary battery. Generally we are used in torches, wall clocks, radios. So once we are using these batteries, we cannot rechargeable again. It becomes dead. That batteries are called primary battery. So you see here, once the reactants have been converted to products, there is no electricity produced. So that means the cell becomes dead. Just use and throw batteries. The cell reactions takes place only one way direction. Once reactant converts to the products, it becomes dead. We cannot rechargeable. So these batteries are called primary batteries. So best example is here dry cell or Leclanche cell and zinc air battery. So generally these batteries, primary batteries used in this torches, radios, transmitters and wall clocks, etc. Secondary battery. So these cell reactions are reversible. Once we are using these batteries, complete so many number of cycles of charging and discharging. So this type of batteries are called secondary batteries. So the cells in which the cell reaction can be reversed by passing electricity opposite direction. Once you are using this battery, that means discharging. So in this case, it needs charging. So when we passing electricity opposite direction, again we can use number of cycles charging and discharging. So these batteries are called secondary batteries. It can be used through large number of cycles through discharging and charging. Best example is lead acid storage battery or lead acid battery and lithium ion battery. So lithium battery is the best example of primary battery, but lithium ion battery is the best example of secondary battery. In this primary battery, lithium acts as anode. But in the secondary battery of lithium ion battery, here lithium not acts as anode. But why we call lithium ion battery? Lithium ions are responsible for charging and discharging. So that's why these batteries are called lithium ion battery. But lithium ion battery are the secondary battery. Lithium batteries are the primary battery. Here best examples are lead acid storage battery and lithium ion battery is the best example of secondary batteries. These secondary batteries mainly used in automobiles and cars, trains, motors, electronic clocks, power stations and laboratories, etc. We can use. So primary batteries means the cell reactions are not reversible. Only we can use one-way direction. The batteries are called primary battery. Secondary batteries means the cell reactions are reversible. So once we can use these batteries, again we can use charging and discharge. Number of cycles we can use through charging and discharging by passing electricity opposite direction is called secondary batteries. So what are the difference between primary battery and secondary battery? So this in this primary battery, the cell reactions are irreversible, cannot reversible. Only discharging process. There is no, you cannot rechargeable. So in this primary battery, first point is cell reaction is irreversible. But in the secondary battery, these cell reactions are reversible. In secondary battery, the cell reactions are reversible and we can use number of cycles through charging and discharging. And this primary battery must be discarded after use. But secondary battery may be recharged. We can recharge, we can use again by passing electricity opposite direction. And third one is in this primary battery a relatively short shelf life. Already we know that it is having short shelf life. But in this secondary battery have long shelf life and functions only as galvanic cell. Galvanic cell means it is also called as electrochemical cells, which means which converts chemical energy into electrical energy, which converts chemical energy into electrical energy. But here in the secondary battery, both the functioning electrochemical cell and electrolytic cell. In this galvanic cell or electrochemical cell means in this case during discharging process while we are using this battery, chemical energy converts into electrical energy or electrolytic cell during charging. In this case, a reverse reaction, electrical energy converting to chemical energy. But primary batteries, it functions only as a galvanic cell or electrochemical cell. That means which converts chemical energy into electrical energy. But in the secondary battery, both the functions of electrochemical cell and electrolytic cell. Electrochemical cell means which converts chemical energy into electrical energy. So while we are using this battery, the chemical energy converts into electrical energy. So in this case, it is storing discharging. So in this case, it batteries needs charging. So again, you pass electricity opposite direction through this battery during charging process. So in this case, electrical energy convert into chemical energy. So both the functions takes place in this secondary batteries as electrochemical cell and electrolytic cell. And they cannot be used as a storage device. These primary batteries we cannot use as storage devices because we cannot rechargeable these batteries. But in the secondary batteries, they can be used as energy storage devices. We can use in energy storage devices. Example, solar, thermal energy, which converted to electrical energy. So these batteries are can used in storage devices. Example, solar thermal energy. You can convert it into electrical energy. And next one is in this primary battery, already we know that it cannot be recharged. But in the secondary battery, they can be recharged. They can be recharged. Best example of primary battery is dry cell, alkaline battery, lithium battery. But in the secondary battery, best example is lead acid storage battery, nickel cadmium battery, and one more example is lithium ion battery. This time is we discussed already. Lithium battery is the primary battery, but lithium ion battery is the secondary battery. Why we call lithium ion battery? Lithium ions are responsible for charging and discharging. So that's why this battery is called lithium ion battery and it is a rechargeable battery. But here lithium battery is a primary battery. In this lithium battery, lithium acts as anode. That's why that battery is called lithium battery. Here lithium ions are responsible for charging and discharging. That's why this battery is called lithium ion battery. And lithium battery is the best example of primary battery, and lithium ion battery is the best example of secondary battery. Now let's discuss best example of primary battery is zinc air battery. So in this we'll discuss how to construct zinc air battery and what is the working function and what are the advantages uses of zinc air battery. So in this zinc air battery, it is a type of electrochemical cell. It is a type of electrochemical cell, that means which converts chemical energy into electrical energy. So zinc air battery is a type of electrochemical cell that generates electrical energy. Through the how to generate this electrical energy through the oxidation of zinc and reduction of oxygen from the atmospheric air. Here in this battery, zinc acts as anode and oxygen, that means air, acts as cathode. For example, see here anode is the zinc metal. Here anode is the zinc plate or zinc metal acts as anode. And here cathode is a porous carbon plate. Porous carbon plate acts as cathode. Zinc is acts as anode and porous carbon plate acts as cathode, and electrolyte is the KOH. KOH acts as electrolyte. This anode and cathode separated by separator. The separator is mainly used for transfer of electrons and transfer of metal ions from anode to cathode to anode, etc. So in this primary battery or zinc, in the best example is zinc air battery. Zinc air battery is a type of electrochemical cell. It generates electrical energy. So already we know that electrochemical cell means which converts chemical energy into electrical energy. So it generates electricity through the oxidation of zinc and reduction of carbon plate or reduction of oxygen at carbon plate. So your anode is the zinc metal and cathode is the porous carbon plate. Electrolyte is KOH, and these two anode and cathode is separated by separator, which allows the transfer of ions through the separator in this electrolyte, through the electrolyte. Okay. So this is a zinc air battery. So how to construct this zinc air battery? What is the main advantages of zinc air battery? Where we can use this zinc air battery? So how to work this one? Here in this battery, zinc acts as anode and oxygen acts as cathode. Oxygen from atmosphere or air. So oxygen undergoes reduction, zinc undergoes oxidation. Finally, it generates electrical energy. So in this zinc air batteries, these are the non-rechargeable batteries and a best example of primary batteries. So primary batteries means non-rechargeable batteries. So in this zinc air battery or zinc metal batteries, for example here zinc air battery, it is a non-rechargeable batteries. And zinc air fuel cells, these are the secondary batteries and mechanically rechargeable. These are the secondary batteries, but zinc air batteries are the primary batteries. And metal air batteries, all these are type of zinc batteries, zinc air batteries. Zinc air battery is the primary battery, zinc air fuel cell is the secondary battery, and metal air battery is also secondary battery. So all these zinc air batteries are powered by oxidizing zinc with oxygen from the air. So already we know that zinc undergoes oxidation and oxygen in this battery reduced. So in this zinc air battery is a type of electrochemical battery. Electrochemical battery means which converts chemical energy into electrical energy. So zinc air battery is a type of electrochemical battery that uses zinc as anode and air generally from atmospheric oxygen. acts as a cathode. So these batteries are having high electrical density or high energy density. These batteries have high energy densities and are relatively inexpensive to produce. This is the main advantage of zinc air battery. These are having high energy densities and low expensive. This is the main advantage of zinc air batteries. And one more advantage is it is available in different sizes. For example, the button sized, the very small button sized zinc air battery cells used in this hearing aids. Very small button sized zinc air batteries used for hearing aids. Larger batteries, so compared to small sized zinc air batteries, it is larger size zinc air batteries used in film cameras. Used in cameras. Very large batteries used in electrical vehicle propulsion and grid scale energy storage. So these are available in different sizes. For example, small size zinc air battery used in hearing aids and larger size batteries used in film cameras and very large size batteries used in electrical vehicle propulsions and grid scale energy storage. So construction of this zinc air battery. How to construct zinc air battery? It consists of two electrodes. One is anode and the other one is cathode. So in this zinc air battery, zinc acts as anode, air acts as cathode. So first point is zinc air battery. It consists of two electrodes, zinc anode and air cathode. So this anode and cathode is separated by separator. So anode and cathode separated by separator. It allows the ions transfer of across the cell, which allows the ions across the cell. And KOH used as a electrolyte. KOH used as a electrolyte. So here zinc anode, where it is undergoes oxidation because zinc acts as anode in this zinc air battery. So in this battery, zinc anode, where it is undergoes oxidation to produce zinc metal ions and releasing two electrons. Generally, in this zinc air battery, zinc undergoes oxidation because it acts as a anode. So zinc undergoes oxidation, then gives zinc metal ions and loss of two electrons. Because oxidation means loss of electrons. So in this zinc air battery, zinc acts as anode, air acts as cathode. So in this zinc undergoes oxidation. So they gives zinc metal ions and loss of two electrons. So these zinc plus 2 ions reacts with OH minus ions from the electrolyte. In this battery, KOH used as a electrolyte. So these zinc metal ions reacts with OH minus ions from the electrolyte, then form zincate. Then form zincate. First zinc undergoes oxidation, then gives zinc metal ions and loss of electrons. It is an oxidation reaction. So these zinc metal ions reacts with OH minus ions from the electrolyte. Here KOH used as a electrolyte. So this zinc metal ions reacts with OH minus ions, then gives zincate, ZnOH4, zincate. So next this zincate ions further decomposition to form zinc oxide and water. This zincate further decompose, then gives zinc oxide and water. And these two are returned to the electrolyte. This zinc oxide and water returns to the electrolyte to produce OH minus ions. To produce OH minus ions. And the released electrons at anodic area, it liberated 2 electrons or loss of 2 electrons. So these liberated electrons move to the cathodic area through the external circuit. Electrons are moved to the external circuit and ions are moved through this separator. So at cathodic area, already in this oxygen acts as, already we know that just now discussed, oxygen acts as cathode. Oxygen from atmospheric air. So at cathode, Oxygen consumes water. At cathode, oxygen, generally here oxygen acts as cathode. So at cathodic area, oxygen interacts with water to produce OH minus ions. To produce OH minus ions. So what is the voltage of this battery, zinc air battery? Theoretical voltage is 1.65 voltage, but it is reduced to 1.35 to 1.4 voltage in available cells. Present available cells, this battery voltage is 1.35 to 1.4 voltage. But theoretically, its voltage of this battery is 1.65 volts. So working function at anodic area. So in this zinc air battery, zinc acts as anode. So at anodic area, zinc undergoes oxidation. It acts as a anode. At anodic area, zinc undergoes oxidation, then gives zinc plus 2 and loss of 2 electrons. It undergoes oxidation, then gives zinc metal ions and loss of 2 electrons. So this zinc metal ions reacts with OH minus ions from the electrolyte. It reacts with OH minus ions from the electrolyte. Then it gives zincate. Next, this zincate decomposed into zinc oxide and water. Zinc oxide and water produce OH minus ions also. And this zinc oxide and water return to the fluid, that means electrolyte. This zinc oxide and water returns to the electrolyte. At cathodic area, already oxygen, we know that oxygen acts as cathode. So at cathodic area, which one is inverse? Porous carbon plus generally acts as cathode. At cathodic area, which one is reduced? Oxygen. So atmospheric oxygen, that means oxygen from atmospheric air. Gain of 2 electrons and reacts with water. Gain of 2 electrons and reacts with water, then produce OH minus ions. So what is the overall reaction in this zinc air battery? Zinc acts as anode, oxygen acts as cathode, then form zinc oxide. And these reactions are irreversible because it is a primary battery. So primary battery means these cell reactions are not reversible. Once we can use this battery, it becomes dead. Only discharge and reactions takes place. We cannot be rechargeable. So what are the advantages of zinc air battery? So first one is high energy density. High energy density. So zinc air batteries are having high energy densities. So which means they can store significant amount of energy relative to their size and weight. The main advantage of zinc air battery, it is having high energy density. And second one is environmentally friendly, eco-friendly. Because in this zinc air battery construction purpose, we are using all the materials are non-toxic metals. So they do not contain toxic materials. They do not contain toxic metals. So it making them more environmental friendly compared to some other type of batteries. Compared to other batteries, it is eco-friendly batteries and not toxic. We cannot use any toxic materials in this construction of zinc air batteries. And third one is lightweight. The use of air as a cathode in this at cathodic area, which one is involves? Air, atmospheric air. So the use of air as a cathode, it reduces the weight of the battery. It reduces the weight of the battery. So it making it suitable for portable and lightweight application. Suitable for portable and lightweight applications. And long shelf life. So zinc air batteries are having long shelf life when not in use also, because they don't experience the same self-discharge rate as some other battery types. Compared to other batteries, it is having long shelf life if we are not using also. In this case also, it is having duration is more. And primary and rechargeable versions. So zinc-air batteries are available in both primary zinc-air batteries are the best example of primary battery, the non-rechargeable batteries, and some of the batteries also available in rechargeable zinc metal batteries. Some of the zinc-air batteries also available in this secondary batteries type also. And common applications of zinc-air batteries, common uses of zinc-air batteries, it's including hearing aids. Just I discussed already, small sized zinc-air batteries used in hearing aids, and some of the zinc-air battery used in medical devices, film cameras, and military applications. So these are the main advantages. It plays an important role, key role in these batteries, and most preferable batteries, and it is having high energy density, and most important advantage is it is available less cost and not toxic, eco-friendly. These are the main advantages of zinc batteries. So what are the uses of zinc battery? So it is used as a power source in hearing aids. It is used as a power source in hearing aids. Button sized zinc battery used in hearing aids. It also used in electronic pages, used in military radio receivers, used in voice transmitters. So these are the examples of zinc batteries. So in this class we learn what is battery, how many types of batteries, what are the difference between primary battery and secondary battery, and best example of primary battery, that is zinc battery. Zinc battery is the best example of primary battery and most preferable battery nowadays. So in this zinc battery, zinc acts as anode and oxygen acts as cathode. So zinc undergoes oxidation and oxygen undergoes reduction, then from zinc oxide finally. It is a primary battery, and the cell reactions are not reversible. And so many applications, so many advantages are there. Already we discussed just now. So I understood. I hope all understood. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.